The Earth's changing irregular magnetic field is causing headaches for polar navigation, according to the College of Engineering, University of Michigan. The Earth's liquid molten outer core, composed mostly of iron and nickel, exerts an electromagnetic field extending from the North and South Pole that protects the planet from harmful solar particle radiation. Fluctuations in the strength of Earth's magnetic field, caused by daily changes in solar wind structure and intermittent solar storms, can impact the use of geomagnetic field models, which are essential for navigation in satellites, planes, ships, and cars. We're talking about GPS. Magnetic field models differ based on the location of data collection, either on or near the Earth's surface or low Earth orbital satellites. Past research has attributed model differences to space weather activity levels, but a recent analysis of 6 years of Earth and satellite magnetic field models found model discrepancies are also driven by modeling errors other than geophysical phenomena alone. The results are published in the Journal of Geophysical Research, Space Physics. The University of Michigan research team assessed differences between observations from the SWARM mission's low Earth orbit satellites and an Earth magnetic field model. The 13th generation of the International Geomagnetic Reference Field, or IGRF 13, they focused on differences during low to moderate geomagnetic conditions, which encompassed 98.1% of the time between the years 2014 and 2020. Satellite observations collected at different locations above our Earth are sensitive to magnetic field fluctuations, whereas Earth magnetic field models use observations to estimate the Earth's internal magnetic field without accounting for the influence of solar storms. Internal magnetic field models like IGRF-13 are used to track changes in the Earth's magnetic poles, like the North Pole shift of about 45 kilometers northeast each year. And we can see the video of this there. Now, understanding these large differences are important for satellite operations when using IGRF-13 as a reference and for research on the physics of the Earth's magnetosphere, ionosphere, and thermosphere. Model uncertainty was highest in the North and South polar regions, and a statistical analysis revealed that the asymmetry between the North and South polar regions was a major factor driving model differences. We often assume a nearly symmetrical magnetic field between North and the Southern polar regions, but they are actually very different, said Yining Shi, an assistant research scientist at the University of Michigan Climate and Space Science and Engineering, and corresponding author on the study. The two geographic poles may map to different geomagnetic coordinates. The North Pole maps to around 84 degrees magnetic latitude MLAT and 169 degrees magnetic longitude MLON, and the South Pole maps to around minus 74 degrees MLAT and 19 degrees MLON. The SWARM satellite's polar orbit track creates a sampling bias with a high concentration of measurements around the geographic poles, which exacerbates the model differences. Understanding that what has been attributed to geophysical disturbances is really due to the asymmetry of the Earth's magnetic field will help us better create geomagnetic field models, as well as help with satellite and aviation navigation, said Mark Moldwin, Arthur F. Thuman Professor of Climate and Space Sciences and Engineering at UM, and an author on the study. Another issue that is causing the navigation community concern is that the polar magnetic field has been changing very rapidly over the past decades or so. This adds further complexity to creating accurate magnetic field models, said Moldwin. This is provided by the University of Michigan College of Engineering, by Patricia Delancey, and it's on phys.org. Please leave your comments. Thank you for your support. support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.